Here is the sentence that unlocks RabbitMQ, and almost nobody says it clearly. A producer never sends a message to a queue. Not once. Not ever. It cannot. A producer publishes to an exchange, and the exchange decides which queues, if any, get a copy. That indirection is not a technical detail. It is the entire point of RabbitMQ, and it is what makes it fundamentally different from Kafka. It is also where all the power lies, and where all the mistakes are made. 9 concepts. 1 running example throughout. An order processing system, where an order event needs to reach billing and shipping, and an audit log, and sometimes a fraud check, with different rules for each. And you will be able to design the routing for that from scratch and explain why a message you published vanished into thin air. Think about what a producer actually knows. The order service knows one thing: an order was placed. It should not know that there is a billing queue. It should not know that shipping was added last month, or that the fraud team wants a copy of orders over £1,000 but not the others. The moment your producer knows about its consumers' queues, you have coupled them, and every new consumer means a change to the producer, which is exactly the thing you built a message broker to avoid. So somebody has to decide where a message goes, and the question is who? Kafka's answer is: the consumer decides. It writes to a topic and consumers choose what to read. RabbitMQ's answer is the opposite and, for a certain class of problem, much more powerful. The broker decides. The producer just describes the message, and a component in the broker, the exchange, applies rules that the consumers themselves declared and routes accordingly. The producer stays ignorant. The consumers stay in control of what they receive. That component is what this whole episode is about. Concept 1. The 4 moving parts and the sentence you must be able to recite. 4 parts. The producer publishes a message and attaches to it a routing key, a short string like order.created.uk, which is the message's address, or more accurately, its description. The exchange receives that message. It holds no messages itself, ever. It is a pure routing function, and if it cannot route a message, that message ceases to exist. The binding is a rule that a queue registers with an exchange, saying, "Send me messages that look like this." Note the direction carefully, because it is the crux of the design. The queue binds itself to the exchange. The consumer's side declares what it wants. The producer had no say, and the queue is where messages actually live, waiting for a consumer to take one. So the flow is published with a routing key. The exchange compares that key against every binding, and every binding that matches gets a copy of the message. Every one. This is not a first match wins system. 3 bindings match. 3 queues get the message. 3 consumers each get their own copy. And here is the consequence that catches everyone out, and it deserves its own sentence. If no binding matches, the message is silently dropped. No error, no queue, no warning. Though that is the single most common RabbitMQ support question there is, and we will come back to it. Concept 2. The direct exchange, exact matching. The direct exchange is the simplest one, and its rule is exactly what it sounds like. Deliver the message to every queue whose binding key is exactly equal to the message's routing key. String equality. Nothing clever. So you bind your billing queue with the key payment, and your shipping queue with the key ship, and a message published with routing key payment goes to billing and nowhere else. This is how you build simple targeted routing. 1 message type, 1 destination. Now, 2 things worth knowing that people miss. First, multiple queues can share the same binding key. Bind 3 queues all with the key payment, and a message with routing key payment goes to all 3. So direct is not one-to-one, it is exact match to many. Second, and this is a genuinely useful pattern, a single queue can have several bindings. Bind your audit queue with the key payment, and again with the key ship, and again with the key refund, and now it collects all 3 message types. So direct exchanges give you both selectivity and aggregation, and the classic use of direct is severity-based logging. Bind an error queue to the key error and a catch-all queue to error, warning, and info. It is the workhorse, and if your routing needs are simple, it is all you need. Concept 3. Fanout, the one that ignores you. The Fanout Exchange is the simplest of all, because it does not think. It takes every message and copies it to every queue bound to it, and it completely ignores the routing key. You can set a routing key. It will be discarded. This is pure broadcast, and it is publish subscribe in its most literal form. When would you want it? When an event is genuinely of interest to everyone and you refuse to encode who those everyones are. A cache invalidation event. Every service instance holding a cache needs to know. A configuration change. A global system announcement. And crucially, Adding a new consumer requires no change anywhere except that consumer binding its own queue. The producer does not change, the exchange does not change, and no existing binding changes. That is about as decoupled as it gets. It is also, being blunt, the closest RabbitMQ comes to Kafka's model. Everyone gets everything, and each consumer has its own queue. The difference is that each Fanout queue is a real queue with real copies of the messages, so 10 consumers means 10 copies stored in the broker, whereas Kafka would store the record once and let 10 consumers read it. That is exactly the sort of comparison an interviewer likes to hear you make unprompted. Concept 4. The topic exchange, the one that does the real work. The topic exchange is where RabbitMQ earns its reputation, and it is the one you will use for anything serious. Star matches exactly one word. Hash matches 0 or more words. And that is the entire syntax. It fits on a slide, and it lets you express remarkably precise routing. So, bind a queue with order.star.star and you get every order event from every country. Bind with order.created.hash and you get order creations from anywhere however deep the key goes. Bind with just hash and you get literally everything, which is how you build an audit queue. Now the reason this matters so much, your consumers select their own slice of the message stream, declaratively, and the producer knows nothing about any of it. The fraud team wants only UK order creations. They ban order.created.uk. They deploy that themselves. Nobody touches the producer. Nobody redeploys anything. Nobody has a meeting. That is the payoff. And the practical advice. Design your routing key hierarchy carefully and early, from general to specific, entity, then action, then region. Because every binding anyone ever writes depends on that structure, and changing it later means rewriting everyone's bindings at once. Concept 5. The two exchanges nobody explains, headers, and the sneaky default one. The headers exchange ignores the routing key entirely and routes on the message's header attributes instead, key value pairs. You bind with a set of headers and a special argument, xmatch, which is either all, meaning every header must match, or any, meaning one is enough. It is more flexible than topic exchange because you can match on multiple independent dimensions rather than one hierarchical string. No, it exists. Know why it is rare. Now the default exchange, and this one is worth real attention, because it explains a piece of magic you have probably already used without understanding it. Every RabbitMQ broker has a nameless direct exchange, referred to as the empty string, and every queue you create is automatically bounded with a binding key equal to the queue's own name. So when a tutorial tells you to publish with an empty exchange name and a routing key equal to your queue name, and it just works, that is why. You are not sending to a queue, even though it looks like it. You are publishing to the default exchange, which is a direct exchange, and matching a binding that RabbitMQ created for you automatically. It is convenient for demos and quick scripts. It is also a trap, because it looks like the producer is addressing a queue directly, which teaches exactly the wrong mental model. Real systems name their exchanges. Concept 6. The disappearing message, and the two settings that stop it. This is the #1 RabbitMQ mystery. You publish a message, the broker accepts it, your code reports success, and the message is simply not anywhere. No queue has it. No error was raised. It is gone. And the cause is always the same. No binding matched, so the exchange had nowhere to put it, and an exchange cannot store messages, so it discarded it. That is the defined behavior. It is not a bug. There are 3 fixes, and you should know all 3. First, the mandatory flag. Publish with mandatory set to true. And if the message cannot be routed to any queue, the broker returns it to the producer instead of dropping it. You then handle the return in a callback, and now you know. Second, and this is the better production answer, the alternate exchange. When you declare an exchange, you can give it an alternate exchange argument naming a second exchange. Anything the first exchange cannot route gets handed to the alternate, which is typically a fanout bound to an unrouted queue. Now nothing is ever lost. Unroutable messages pile up somewhere visible, and you can alert on that queue stack. That single configuration turns a silent, invisible failure into a monitorable one, and it costs you nothing. Third, less a fix than a discipline. Publisher confirms. Confirms tell you the broker accepted your message, but be careful, because a confirm does not mean it was routed. An unroutable message on a broker with no mandatory flag will be confirmed and dropped. Confirms guarantee the broker got it, not that anyone will. Those two things are different, and knowing the difference is a very good interview signal. Concept 7. The dead letter exchange, where failed messages go, and the beautiful trick it enables. An alternate exchange catches messages that were never routed. A dead letter exchange catches messages that were routed, delivered, and then went wrong. You configure a queue with an X dead letter exchange argument, and a message in that queue gets dead lettered, republished to that exchange, in exactly 3 situations. 1. A consumer rejects or negatively acknowledges it with requeue set to false. 2. The message's time to live expires. 3. The queue is full and hits its length limit, and RabbitMQ helpfully stamps the message with an X death header recording why, how many times, and from where. So your dead letter queue is not a mystery pile, it is a diagnosable one. Now here is the elegant part, and this is a genuinely great thing to be able to explain. RabbitMQ has no native delayed retry. You cannot say try again in 30 seconds, but you can build one out of 2 dead letter exchanges. Create a waiting queue with a message TTL of 30 seconds and no consumer at all, and set its dead letter exchange to point back at your main exchange. Now when your consumer fails a message, it publishes it to the waiting queue. The message sits there. Nobody consumes it. 30 seconds later its TTL expires. An expiry is a dead letter trigger, so it gets republished to the main exchange and lands back in your work queue, ready to retry. You have built a delay queue out of a timeout and a routing rule. Track the retry count in a header, and after 5 attempts route it to a real dead letter queue for a human to look at. That is the standard RabbitMQ retry pattern, and being able to draw it will land very well. Concept 8. How to actually design your routing. The mistakes to avoid. Some rules, learned the hard way. 1. Use a topic exchange by default. It behaves exactly like a direct exchange if you use no wildcards, so you lose nothing, and you keep the door open for wildcard bindings later without a migration. Starting with direct and needing topic later means recreating the exchange, and exchanges cannot be modified after declaration, a fact that surprises people. 2. Design your routing key hierarchy before you write any code. Entity, action, then qualifiers, order.created.uk. Get wrong, and every binding in your estate depends on the mistake. 3. Durable exchanges, durable queues, and persistent messages, and you need all 3. A durable exchange survives a broker restart. A durable queue survives a broker restart. But a persistent message is a per message flag, and if you forget it, your durable queue comes back after a restart perfectly intact and completely empty. All 3, or you have none. 4. Never let the producer know about queues. If your producer code contains a queue name, you have leaked your consumers into it, and you have thrown away the entire benefit of the exchange. Publish to an exchange with a descriptive routing key, and let consumers bind whatever they want. And 5. Always configure an alternate exchange and a dead letter exchange from day one. They cost nothing when everything works, and they are the difference between debugging a problem and staring at a message that no longer exists. Concept 9. The comparison, because they look similar and are not. People say a RabbitMQ exchange is like a Kafka topic. It is not, and here is the precise difference. A Kafka topic is storage, an actual durable log that holds records. A RabbitMQ exchange is a function. It holds nothing, ever, and if it cannot route a message, that message evaporates. The storage in RabbitMQ is the queue, and queues live downstream of the exchange. So who is smart? In RabbitMQ, the broker is smart and the consumer is simple. The exchange evaluates bindings and decides who gets what, and the consumer just takes whatever arrives in its queue. In Kafka, the broker is deliberately dumb and the consumer is smart. The broker appends to a log and does no routing at all, and the consumer decides what to read and where to start. Neither is better. They are different philosophies, and the trade is clear. RabbitMQ's model gives you rich, declarative, per-message routing that consumers control, plus per-message acknowledgement, rejection, TTL, priority, and dead lettering. Kafka's model gives you replay, enormous throughput, and long retention, because a dumb broker that only appends to a log is very, very fast. So the rule of thumb, and this is the sentence to say, use RabbitMQ when the routing is complicated and each message is a task that needs individual handling. Use Kafka when the routing is trivial and each record is an event that many systems will read, possibly more than once. If you find yourself wishing Kafka had a topic exchange, you have picked the wrong tool. And if you find yourself wishing RabbitMQ could replay last week, so have you. Let us put it back together. A producer never sends to a queue. It publishes to an exchange with a routing key, and the queue binds itself to that exchange with a rule. The consumer side declares what it wants. The producer stays ignorant. Every matching binding gets a copy, and if nothing matches, the message is silently destroyed. Direct is exact string matching. Fanout ignores the key and copies to everyone. Topic uses data keys with start for one word or many. It is the one you actually use, because it behaves like direct until you need more. Headers exists and is rare, and the default exchange is a nameless direct exchange that auto-binds every queue by name, which is why publishing to an empty exchange name looks like sending to a queue, and it is teaching you the wrong model. Configure an alternate exchange so unroutable messages become visible instead of vanishing, and a dead letter exchange so failures become diagnosable. And chain a TTL queue back through a dead letter exchange, and you have built delayed retries out of nothing. Durable exchange, durable queue, and persistent messages, all three or none. And remember the real distinction. RabbitMQ has a smart broker and a simple consumer, and Kafka has a dumb broker and a smart consumer. Subscribe!